represented by y is equal to x to the power m by n. There can be two possibilities. First, if m is greater than n, and in the second case, if m is less than n. For the first case, the graph would be this, and in the second case, the graph would be this. I assume a point xi, yi on both the graphs. And representing this area as A1, this area as A2, this area as A3, and this area as A4. The question is, what is the ratio of these areas? The ratio of these areas, that is A1 by A2, is equal to m by n. And in the second case also, the ratio of the areas A3 by A4 is equal to m over n. How does it come? This can be simply proved using integration. Now, if I talk about the ratios are m over n, for the first case, as m is greater than n, then this ratio would be greater than 1, so a1 would be greater than 2. And for the second case, as m is less than n, therefore a3 would be less than a4. This can also be observed on the graph. As this is a concave side, therefore the a1 would be greater than a2, and as this is a convex side, therefore a4 would be greater than a3. Now, what exactly is a1 in terms of x1 and y1? We can say that a1 is simply nothing but m over m plus n times area of the rectangle, that is xi, yi. Now, applying it on a graph y is equal to x squared. Here, as you can see, m comes out to be 2 and n comes out to be 1. Therefore, the area of the red region comes out to be 2 over 2 plus 1 times xi, yi. That is 2/3 of the area of the rectangle. Now let's pick up a question. Find the area bounded by y is equal to x squared minus 4x plus 3 and x-axis between the roots of the quadratic equation. Let us assume the root to be alpha and beta. And let us construct a rectangle whose sides are parallel to the x-axis. Then, let us say the length of this triangle is capital L and the breadth of the rectangle is capital B. Clearly we can say that capital L is nothing but difference of root, that is root d by a. And capital B is nothing but distance of vertex or the minimum value of the graph, which is minus d power 4a. Now, the required area is nothing but the green area, and I can write area of green is nothing but 2 over 3 times area of rectangle. Which comes out to be, substituting the values 2 by 3 L into B, which is 2 over 3 times root d by a into d by 4a, which is nothing but d root d over 6a square. This is a very important result. Let us pick up another question. Find the area bounded by y is equal to x squared minus 4x minus 1 and y is equal to 2x plus 29. So, the area would be simply integral x1 to x2 quadratic minus senior dx. Now, The above method, which I have told you, the area comes out to be d root d over 6a square. It can be applied to this question also, as I can treat the line to be the x-axis and x1 and x2 to be the roots of the quadratic equation q dash x, where q dash x represents qx minus lx. Then the area would be simply area of the answer would be d root d over 6a square, where discriminant would be of the new quadratic q dash x. I will be coming up with a question of JEE Advanced Board of this year 2025 in the later video. Please support the channel for more such short and nice concepts.